Okay, today we're going to get into magnets, particularly the property of magnets. Magnets are just kind of fun, cool things. Little bits of vocabulary you need to be aware of. And on your desk you should have plenty of things to play with. Okay, modern technology. Now, a magnet is something that attracts other metal. And it's usually made of what we call a ferrous material. The old kind of black ones is a ferrous material. This is how you tend to find it in the wild. It doesn't feel like quite regular steel. This is easily magnetized. But ferrous is a fancy word for iron. If you look on the periodic table, the letters that represent iron, IR, it's Fe. It's a ferrous metal. And that's what can be magnetized. Magnets come in all sorts of shapes and sizes, particularly nowadays. Our chalkboard is also magnetic. You have little what are called super magnets. These real little ones like this that are super strong, even though they're small. We can put magnets in things to make little things. This is for building structures. They can link together so we can make different stuff out of them. And we have the traditional U-shaped magnet. They can come in all sorts of sizes. This is used a lot in, believe it or not, in fishing and in salvage. If you want to recover stuff from the base. Elu, do you have a note?
Yes.
Okay. Often when something gets sunk, like an outboard motor, they would just tie this to a rope, drop it off the boat, pick up all the metal from the ground or from under in the lakes. Great for salvage tools. We have also one that's called an electromagnet. The key being electro. This is a temporary magnet. We wrap metal with wire. When we run an electrical field through it, it magnetizes that piece of metal. You see these in dumps. I hope we can do a lab where we make one of those pretty soon. But today that's a temporary one made with electricity. If you remember when we built our little motors, we had a reaction between the magnets and the electricity in the coil. This is sort of the reverse stuff. We can use electricity because it has similar properties as magnets. We can use electricity to make magnetic fields. Of course, we'll be talking about magnetic forces, the strength of the magnet. Real complicated math on that. We will probably not get into it, but this is physics, so I got to throw in a little pitch for forces. Magnets have what we call poles. And you often see them represented different ways. Sometimes as positive and negative, sometimes as north, and sometimes as south. What is cool, it doesn't matter how big the magnet is, what shape the magnet is, it will always have two poles. If I break this into two magnets, they will still have positive and negative. We do not have what we call a monopole. That's an area of physics people are trying to study, see if it's actually possible. But no matter how small we make it, it's always going to have a positive and a negative. And because of this, we can use this as a compass. That's why we often will call them north and south. On your desk, you guys should have a little compass. What it is on our planet, this could be bad. Over in Russia, there's this big magnetic deposit, and it's kind of near the North Pole, and it's actually strong enough we can pick up that along the world. In biology, there's theories that many animals use this to navigate. This is how birds can fly north and south. And what happens if you suspend a magnet from a string? it will point to the north, or close enough to the north for navigation. Not true north, but pretty close. There's a small adjust. So we can use these for compasses. If you could actually X-ray a magnet, oops, positive and negative. I mentioned before you break it in half, it has positive and negative. It's actually all these little chunks. Positive, negative, positive, negative, positive, negative, positive, negative. And these are called domains. So this is what the magnetic domain is. It's made of tons and tons of little domains, little kingdoms. Many, many little magnets go together. You guys have magnets on your desk. You notice you can stick two of them together and make one big magnet with a positive and negative. We can also, I mentioned on electromagnets, it's a temporary magnet. There's a way of using electricity to make permanent magnets. If I make a permanent magnet, that process is called magnetization. Essentially, that's the process of making a magnet. And one of the cool things to play with is we have what are called magnetic fields. I mentioned on the Earth, over in Russia, we have a big clump. And it causes these magnetic fields to it. We can see these fields on your desktop. You should have a little folder with a bunch of metal flakes in it. If you lay a magnet in it, you are going to see those metal flakes. They're going to form lines like this from pole to pole.
Where'd you get this, mister?
A science supply shop. You used to be able to get it in like the Disney store. You can make them too. Just get some ground metal, put it into a little bag.
They used to have, like, what was it called? Like, they had a picture of a man and you could use, like, little magnets.
Right, to make the beards on them and stuff like that.
That's
It's the same exact thing. You're using the strength of magnetic field to move around the little chunks of metal that
So
are...
we were learning something that we didn't even
You were learning something that you didn't even know about. And by moving it, you can see the magnetic fields. If you chip the magnet, you'll see it different. You can kind of see the strength. More clumps will go where it's stronger. Less clumps as it's weaker and goes out. So you have magnets on your desk to play with and see these. You will also see if you take your compass and put it near your magnet. The magnets on your desk are stronger than the ones on the Earth right now because they're closer. So your little compass will pretty much point to it. You can move your compass around and it's going to point toward the north on your pole. Any questions on that? It's a pretty much introduction to magnets and some basic vocabulary on magnets. Awesome. So what you're going to have to do today is you're going to read Properties of Magnets. And it's going to cover, it's online, it's an ebook again. It will cover exactly what I told you now. Then you have a short little worksheet, Properties of Magnets. Like always, you'll get 2 attempts. When you are done with that, I'd like you to do a little research. Go onto the internet and do some research on magnets' role in today's industrialized world. It's quite amazing what we use magnets for. It's a big technology. You're looking for an area in the future where you want to be an engineer or an inventor or find something that can make you filthy, filthy rich. Magnets is one of the ways. It's a bigger field. We're finding very cool. You often hear about super magnets now. Those high-speed rail trains, they're running up on a magnetic field. America's looking at going into those high speeds. With magnetic fields, we can create almost a frictionless surface, which is becoming very important in engineering for making stuff move. So you're going to do some research on the role magnet plays in today's modernized world, and then you're going to write me an essay, 1 to 2 pages. Do it in Office 360 Word, and then you're going to share it with me at JCook. So, after my wonderful lecture and your toys on the desk to play with, read Properties of Magnets, do the worksheet on it, then get on the internet, do some research. 1 to 2 pages typed in Word, you'll share it with me. Please remember, Word does have spell check. Also remember, when you submit a document to a teacher, make sure it has a title, make sure it has your name on it, make sure it has your period of your class. I get a lot of papers submitted with nothing on them. They're great papers. I have no idea whose they are. I don't link them. Once I get them, I print them out. And then when I grade them, I have a whole stack of ones I printed out. That means I don't know whose email I got it from. So if you don't have it identified on the paper, I'll just throw it in the trash and you have a 0. And then you come whine to me later, I turned it in. I don't see a paper with your name on it. Questions? Okay, welcome back. This is 8 weeks to go.